Describe the translations and sketch a graph of the exponential function y is equal to the natural exponential raised to the minus x plus 6. So the first thing we want to do here is identify the basic graph. And so our basic graph here is a special type of exponential function, the natural exponential. So we can make a little note here to ourselves that this again is a special exponential function. Right? We know that we have a common exponential, a to the x, where a is an element of the real numbers such that a is greater than 0 and a cannot be equal to 1. And so in this case, a is the real number e. This is called the natural exponential. And we'll make another little love note here to ourselves that e is a real number. E is approximately equal to 2.7182, and it's an irrational number, so it continues without rhyme or reason, infinitely and forever. So this is our basic graph. And because all exponential functions have the same shape curve, we already know what the graph of this exponential, or this natural exponential, looks like. It looks just like a growth curve here. So this is the graph for our basic function, y equals the natural exponential raised to the x. And we'll keep in mind here that we have a y-intercept at 0, 1. Again, that's because anything raised to the 0 will equal 1. So if we have the natural exponential raised to the 0, we find that our y value is 1. So then looking up at our given function here, again reading the graph from the left to the right, we notice that the first translation is this negative on our x value. So we have f of minus x is equal to the natural exponential raised to a negative x. And keeping in mind our translations and transformations here, we know that if we multiply the input value x by a negative, it is a reflection across the y-axis. So that is our first translation. And again, sketching a graph of this, we use the sketch of the basic graph and we create a mirror image right across our y-axis. So you have that same shaped curve going in the opposite direction. And our y-intercept here is still at that same ordered pair, 0, 1. So this is the graph of y is equal to negative x. And we should add here that this first graph is known as a growth model. So the exponential curve in general is called a growth model. And when it is reflected across the y-axis, we call this a decay model. And we call this curve a decay model because we can see that as x gets infinitely larger, approaches infinity, the y values are getting smaller and smaller. They're approaching 0, but never crossing that x-axis here. We have a horizontal asymptote at y is equal to 0. So then, looking back at our given function here, and we continue reading this graph from the left to the right, the next thing that we notice is that we're adding a value of 6 to the x in the exponent. So let's move this up for more room. And we can say, again, using or referencing our translations and transformations, we note that if we add or subtract a constant to the input, or to x, we have a horizontal shift. So if it's a horizontal shift, we want to think about the x-intercept to determine if it's moving left or right. So I have negative x plus 6 is equal to 0. And if we subtract x from both sides, we see that x is equal to positive 6. So this tells us that the graph is going to be shifted to the right 6 units. So that is our second and final translation here. And to sketch a graph, we're going to use the curve of our previous step. And we'll make a note here. We're shifting 6 units to the right. So we'll say that's where x is 6, and we'll draw a dotted line, an invisible line here at the value x is equal to 6. So we know our y-intercept here at 0, 1 has shifted over 6 units. We should mark our y-axis as well. So this new ordered pair, this new intercept is going to be at the value 6, 1. And the general shape of our curve has not changed here. It's still that decay model. It's just shifted 6 units to the right. And never crossing that x-axis. We can even extend that out. So this is our final sketch of the given function, the natural exponential raised to the minus x plus 6.